Yeah, so our project was on BCIs for AI alignment, or more generally neurotech. So let's see, what are we trying to do? Mapping BCI neurotech approaches that can improve the likelihood of successful AI alignment, but specifically within AGI timelines. So this is these top-down approaches we've been talking about. It's not really done today. There's quite a few limitations. Access to human data is a big one. Funding, lack of testable hypotheses and experiments. And we really focus on this last one, although we do touch the others. Some of the motivation behind this was really that we don't recognize even really having a foot in any specific door that we know is going to work scientifically for BCI for neurotech. So go test all the doors, find which one you can actually get your foot in. Seems actually like the best thing that we should be doing right now. A more formal way of thinking about that is that we are in a very early nascent stage of this particular subfield. And so in any scenario in which you have many discrete choices, limited resources, and limited information, you can generalize this to a multi-armed bandit problem. And the solution to a multi-armed bandit problem is to look at upper confidence bounds as an algorithm is one of the best. So to maximize the probability of overall success. So we posit that one, that BCI for alignment represents many choices, has finite resources. It basically matches all of these criteria, and specifically that it's in a very early stage, and that most of those confidence bands are very high and very large, meaning uncertain. So we should explore the many approaches in parallel, and we think that that is actually pretty tractable. So, now what did I do?
Particularly because it is potentially quite cheap.
Yes. Yeah, I think that the cost of this is definitely sub-$1 million, and for most things probably sub-$100,000 to test the door effectively. So now we can go into like some of the specific experiments. We came up with a list of different approaches for BCI for AI safety. We're not going to talk about all of them. We probably, in fact, one of the things that we suggest for the 1K, 2K grants is to effectively use the community to workshop or create a BCI for AI alignment tree to look at all of the different possible solutions, evaluate that solution space based on cost and likelihood of impact, and then start kicking on doors effectively. So now we can go into the specific. We came up with a list of 3 experiments that we think actually do have testable hypotheses, and then I'll just pass it over to each one of us that wrote each one. Who wrote this first one? Was it me? Yeah, this was based on our discussion. Maybe you want to do this one?
No, you are going to next, go for it.
Okay. So the first one is increasing human capacity, so using BCIs to increase human capacity. There are 2 parts of this. One is the question, can BCIs increase human capacity? And we talked a lot about this before we kind of realized that academia has actually done, in some ways, a pretty good job at showing the inroads to making that happen, and that there are specifically non-motor approaches to BCI that have really high bandwidth or could have very high bandwidth in a near-term future. So instead, the second part of this is maybe actually what's more interesting is if you had access to a BCI that increased your capabilities, would that actually contribute to AI alignment? So for this one, it's not even really a BCI experiment at all, but to create a set of experiments, one for each BCI-like capability, so these are analogs, things like working memory, computation, imagined vision that could exist with BCI in the near-term future. And the objective variable in that experiment would be the presence of that BCI analog interface. So for things like working memory, you give a group a pen and paper, something very simple. And then you compare that to a control group that doesn't have it, and then those groups are trying to solve an AI alignment analog problem, one in which we know the ground truth, effectively we know the solution, unlike alignment where we don't know the solution. And then you look if there's a difference between those things. If you can't make some version of this experiment work, you probably aren't going to make a BCI version of that experiment work either, unless that BCI is so substantially larger of a jump in humans' ability to think than was pen and paper or print, which were already quite large. So that's one kind of baby step experiment that would be very, very cheap to run. Another one is an autoregressive choke point. You want to do this one?
Yeah, all right, sure.
Yeah.
Okay, so this was inspired third hand, maybe by a suggestion I think from Gwern, where it's like, okay, maybe an avenue for alignment is that you should not allow the ASI to represent brain states which are too unlike brain states that a human could have, and so if you can train an autoencoder that effectively captures possible human brain states, and then use that either as a kind of monitor or a constraint or some kind of loss function modifier, then you could like prevent superintelligences from having sufficiently alien brain states, or like brain states which humans would not have, or something like that. Anyway, you could design an experiment to falsify at least some part of that hypothesis pretty quickly by taking existing data banks of either ECOG or fMRI data and training an autoencoder on this, and seeing if, for instance, you could there are emotional recognition data sets, and so you could like train an autoencoder only on a bunch of happy images, and then show the model the state from some humans that were exposed to violent images, and see if that's now like obviously not encodable. Like you get really high errors when you try to run that through an autoencoder. And that would be some kind of indicator that this could maybe be a sensor. And we had one more, yeah? Simulating a generative human evaluator model.
Oh yeah, this one I can.
All right, cool.
I don't know if there's a ton of context here.
Right.
We're getting down into the lower resolution part of what we've written, so apologies if this isn't a complete thought. But another thing that has been brought up in various forms in using BCI for AI alignment is to create a generative model that was built or trained based on a large corpus of human data, and then use that generative model as a proxy for human stand-in. So whether this is RLHF or human in the loop or brain in the loop, that is very, very tricky to scale to many, many humans, especially if it requires implants or large MRI-like machines over short time scales. But you could train a generative model based on human brain data that you could then scale arbitrarily large for basically compute costs. Now, that might work and is actually quite tractable on small scale in a short term. There are some risks here, and in fact, I'll give credit to Davidad for this one, that the hypothesis is that a generative model trained on lo-fi data will inherit all of those lo-fi flaws, so basically all of the problems with your recording method or experiment methodology, and will therefore misalign the AI specifically and cause it to run off course automatically. So if that happens in a small scale model, it's also very likely to happen in a large scale model and would be good to know. Also very straightforward to run this experiment. And that is kind of like there was an RLHF example of an inescapable wedding party that was basically trained on human sentiment. Turns out human sentiment's very high during wedding parties, and a version of GPT could basically always come back with, well, just have a wedding party then, which is not the result that you want. So that would be another runnable experiment. But these are just three like very quick, probably non-optimal, non-complete examples of experiments that would need to be much better fleshed out, and therefore should just serve as example cases, not final cases. In fact, you'd want many, many more. I think 10 plus as a minimum to start would be ideal.
We have about 2 more minutes left to get through it. How are we going to get there?
Okay. So then success looks like actually disproving a majority of BCI approaches. Knowing what not to do could narrow the solution space quite a lot and start funneling resources into far fewer approaches. And in the meantime, as we disprove many, we'll probably come up with much better solutions in the process. This is for anyone who believes in short timelines to AGI. How does this project contribute? We've kind of gone through that. Feasible on short timescales, identifying promising approaches that can quickly scale up. It probably doesn't contribute to AI capabilities in the short term. There are probably ways in which it would, but those aren't obvious yet. I think really this one is like super, super tractable, that this project needs a neurotech for AI safety tree. This is what's actually going to fill out that solution space. If that existed, like this project is already off to the races, and you can just start funding the ones that seem promising at the outset, are very relatively low cost, that you can basically kick on the door for less than $100,000. So initially, this is less than $1 million per experiment, and usually much, much less than that. Some of these you could probably run for $10K and a couple weeks of someone's time, the ones that are just purely computational. Midterm final exams, I don't know how much, maybe this is maybe more interesting. Using the $1,000 or up to $3,000 awards, starting with the Neurotech for AI Safety tree, including conducting interviews that could generate more exploratory ideas. then defining MVP experiments, so basically better versions of what we've been talking about that have testable, importantly, testable and falsifiable hypotheses for each. And then from that should come a fundraising plan to start lowering that funnel down to fewer results with bigger funding and start expanding up. So this is moving from the exploration phase to the exploitation phase of a bandit problem. And yeah, I think organizing a group strategy session in person after the BCI Society conference was probably added, I'm guessing by you, but I'm not sure who, would also be a very tractable thing in the very near term. So,
Thank you.
cool.
Any questions, comments?
And also, everyone in the group should answer questions.
Right.
What's the minimum quality feedback data that you think would be useful to get started with? Like would like one of those $500 or $1,000 EEG headsets be a good start?
I think you can do it much cheaper than that by using open source fMRI data. Whole brain data is probably going to be more valuable. It's a little bit trickier to work with, but it's essentially free in many cases. There are large corpuses of data already online. So again, as an MVP, I think it's a richer data
Corpus
set.
data, preference data?
Maybe not preference data.
Emotional recognition.
Yeah, so you have emotional valence for both ECOG and fMRI datasets. And then you also have some for EEG, they're much lower quality. And that would be easier to scale if it works well. So I think it's worth doing one experiment with just a commercial EEG headset. But most of the values probably relies on deeper datasets of fMRI.
I want to have that. One of the things I was excited about would be like going even lower thigh and looking at galvanic skin response or even skin conductance, just because wearables might make that like a ubiquitously available kind of monitoring and data collection device for some kind of ubiquitous supervision kind of apparatus. And so if you could get some kind of useful supervision data out of skin conductance or galvanic skin response, that seems like it could be interesting.
I'm thinking eye tracking, and you know that pupil dilation is correlated with glucocerebus activity.
Yeah, that came up too.
Yeah, so there's uncertainty into which one of those will be useful, which is why we want to test most of them.
And one thing I would like to be in this is, my standard example when I'm trying to explain value alignment using BCI is the example of a robot seeing my value system and thinking, should I push the little old lady into the road in front of a car or help her across? And it notices like, okay, Anders approves of one action but not the other. That is interesting, but it also starts like the lead up of a typical alignment disaster story, because then it's going to be maximized for wrong thing. What you want is the causal link, but the reason I'm wanting to help a little old lady is some kind of compassion, a different part. There is something about underlying causal structure in motivations that seems to be important for getting alignment right. And that is something that these kind of tests might be able to set up a situation for checking that we're getting.
Yeah.
So I was wondering, we've been talking a lot about AI alignment, and in the context of this presentation specifically, figuring out how to like shift motivations of the AI towards something that's more tractable for humans, or more palatable for humans. So we've heard a lot of people talking about how maybe there's like some concern, especially you, Robert. Maybe there's some near-term concern. What exactly is the motivation of AI right now? Like, where can we, like, because right now it feels to me like AI is very much a tool. Like, you train it to do a certain task, and maybe it can do that task very well and in a very broad sense. But I guess I'm maybe not coming from an AI background. I'm missing something. What exactly are the values of AI now and in the near future that people are worried about? Like, why are we worried it's going to harm us?
Is the question like why like non-AGI, like basically today's AI is already?
Yeah, today and like the next 2 years, next 2 to 5 years.
I think actually like in the book, The Alignment Problem, literally the name, is really great. They provide an example of Compass, which was a system in the US that was AI designed to look at the likelihood of someone to reoffend if they committed a crime. And then judges started using this, and it basically predicted that everyone of color was likely to reoffend, so therefore it's this extremely racist AI because it's trained on centuries worth of racist data. And then they said, okay, well then let's cut out the like race, and then it basically found through latent variables in the structure, like if you live here and have this last name, you're more likely to be X color, therefore it was still racist. Then they balanced it by race. And so it is defined to be non-racist, but then it started causing like upticks in crime in underserved neighborhoods, and then they scrap the whole program.
Well, I know
This is a
that-
very dumb AI, but like has very serious consequences.
I know that kind of thing, but why is it like an existential threat then?
The standard argument goes something like, you ask it to make more money for my company. I'm a CEO, and I've brought this AI in like an executive consultant to help us out. And the AI decides that, well, if I'm going to make more money for this company, first off, I better make sure that I can't be shut off, because if I'm shut off, then I can't make more money for the company. And also, I should make sure that my goals can't be changed, because if my goals could be changed, then I might no longer make more money for the company. And also, to make more money for the company, perhaps I should convert every atom on Earth to some other structure that more resembles money.
I see.
It seems it's the nature of an optimization process that's sufficiently powerful to destroy everything else that it's not optimizing for, to sacrifice it for the thing it's optimizing for. And for a real world example, like, why does Dow Chemical poison like thousands of people in India that can't fight back? Well, it's the most profitable action. Why don't they like spend a small amount of money and take to fix the thing that was announced at one point falsely and it dropped their stock price down? Can you just stop them? No, they'll sue you. They have like more money than you do. So these companies have already embedded themselves and twisted things towards bad ends. So
This is the
Yeah.
convergent instrumental drive argument.
Okay. This is very informative.
give them another like 1,000 yellow points on every person that's alive, and it's not going to end well for us.
All right,
Don't
leave it at that.
mess
I would
with
say with the tech trees, we can definitely help. We now have a discourse graph tech tree that has ChatGPT inside of the tech tree, so it auto-generates tech trees.
Are you telling me that you have aligned an AI with generating more tech trees?
Something like that.
To be seen.
Sure, we see. Okay, thanks.